Hello friends, today I am going to discuss in a very detail more detail about differential equation. In my first video, I have discussed about the introduction part. So let's start the discussion. So differential equation, this is part 2. Today we will discuss the topic of differential equation, that is equation reducible into homogeneous equation reducible into homogeneous equation. This kind of differential equation means, firstly, I'm telling you what is homogeneous and what is inhomogeneous. This is you have to know. So today our topic is equation reducible to homogeneous equation. So whenever, suppose, I will discuss more about what is homogeneous and inhomogeneous and its difference later, but for the time being, know what is homogeneous. If you write a differential equation dy by dx plus py equals q, such as you are writing so in the right hand side you are saying that you are watching that a constant term is there, but if this constant term vanishes, if this constant term goes to 0, vanishes and becomes 0, then in the right hand side you are getting 0, then it is homogeneous. I'm telling that I will discuss, there is lot to discuss about homogeneous, but for the time being, know this thing only, because today's our topic is equation reducible into homogeneous equation. So what is the step? So for equation reducible into homogeneous equation, such as the form is dy by dx, if the form is dy by dx equals ax plus by plus c divided by capital Ax plus by plus c prime. If such kind of form is there, if you find such form, dy by dx equals ax plus by plus c divided by a into x plus by plus c prime, where a, b, c, c prime, these are all constant, then you have to take equation reducible into homogeneous equation. So what is the steps to solve this type of equation? To solve this type of equation, first step one is, let me clear this. Step one is, first put x tends to capital X plus h, then put y tends to capital Y, or you can say equals also y plus k. So first step, you have to put small x equals capital X plus h and small y equals capital Y plus k. So you are getting new variables. New variables are what? Capital X and capital Y. So this is our first step. So after this step, what you have to do? So you are getting new variable. So here old variable differential equation dy by dx equals d capital Y by dx. You have to do this in second step. This is step 2. In the step 2, you have to do this. Dy by dx equals capital small of d capital Y by dx. This is step 2. So what is the step 3? Step 3 is that when you are writing dy by dx, that form, now you have put x equals x plus h and y equals y plus k. So you will get such a form: a into capital X new variable plus small b into capital Y new variable plus c plus ah plus bk divided by capital A into capital X plus capital B into capital Y plus c prime a h plus bk. You are getting this form now. So whenever it is your third step, whenever you are getting dy by dx equals ax plus a into small x plus by plus c by capital A into small x plus by plus c prime, whenever you are getting, then all these three steps you have to done to do the solution. So after third step, you have the step 4 is what? Step 4 is that c plus h, let me erase, you have to do c plus ah plus bk equals 0. You have to put, and c prime plus ah plus bk equals 0. You are getting at that step 3. So by solving this, you have to get h and k. Now after that, by solving that h and k, that put dy by dx equals ax plus by and by a capital X plus by. So if we take an example, let us take an example, then you will get how to do it. So first type of example is dy by dx equals x plus 2y minus 3 divided by 2x plus y minus 3. So you are getting this from ax plus by plus c divided by capital Ax plus capital By plus c prime. Now compare this with this. What you will get? Comparing these and these, you will get a equals what? 1. A equals what you are getting? 1. B equals 2. C equals minus 3. Capital A equals 2. Capital B equals 1. C prime equals minus 3. So I'm again writing that form. Dy by dx equals x plus 2y minus 3. Equation reducible into homogeneous equation. This form you are getting 2x plus y minus 3. So now what you have to, what is the first step you have to do? Put small x equals capital X plus h and small y equals capital Y plus k. First step you have to do this. Small x equals capital X plus h, small y equals capital Y plus k. So after putting these two terms here in the equation, you will get what? Dy by dx equals x equals capital X plus h, you are getting, plus 2y, that means 2 into capital Y plus k, that means I am writing directly 2y plus 2k minus 3, and divided by 2x plus 2h, after putting that, plus y plus k minus 3. You are getting this. Now what is our second step is? Our second step is now put the form dy by dx equals ax plus b capital Y plus c plus ah plus bk, this format, and capital Ax plus by plus c prime plus h plus bk, this format. So do this format, capital X plus that previous problem, you are getting that format, x plus 2y, this term, plus erase it, plus h plus 2k minus 3 divided by 2x plus y plus 2h plus k minus 3, this format. So now what is our third step to do? Third step is this part is being equal to 0 and put this part equal to 0. So doing this part equal to 0, what you will get? You will get h plus 2k minus 3 equals 0, and you are getting 2h plus k minus 3 equals 0. So by solving it, you will get what? By solving it, you will get h equals 1. This equation, I hope you can solve. H equals 1, k equals 1. By solving it, you will get. Now put this h equals 1, k equals 1 value. You will get what? You will get dy by dx equals capital X plus 2y plus h plus 2k minus 3 equals 2x plus y plus 2h plus k minus 3. Now put 1 h equals 1 and k equals 1. You will get what? You will get dy by dx equals, let me erase it, this equal sign. Dy by dx equals x plus 2y plus 1 plus 2 minus 3 divided by 2x plus y plus 2 plus 1 minus 3. So you are getting what? Dy by dx equals x plus 2y by 2x plus y. So at the last you are getting this dy by dx equals x plus 2y by 2x plus y. So you are getting dy by dx equals capital X plus 2y divided by 2x plus y. You are getting this. Now the next step is here. Here what you have to do, you have to solve this. So how can you solve this? To solve this, you have to put. Now one thing you have to remember, that in the theory portion we have done the second step as dy by dx equals d capital Y by dx. As we are equating the variable, old variable, new variable, differential derivative of old variable, new variable. So now what you will get? You will get d capital Y by dx. Let me write clearly. Very bad handwriting, I know. D capital Y by dx equals x plus 2y by 2x plus y. Now to solve this, put capital Y equals v into x. To solve this, put capital Y equals v into x. Now putting capital Y equals v into x, what you will get? dy by dx equals v plus x dv by dx. By putting capital Y equals v into x, you will get v plus x dv by dx. So now putting this, you will get what? D capital Y by dx equals x plus 2y by 2x plus y. So you will get v plus x dv by dx equals x plus 2vx by 2x plus vx. So you will get by solving that if you take x common here, if you take x common, 1 plus 2v divided by 2 plus v. I am erasing this portion. 1 plus 2v divided by 2 plus v. Here x cancel out. So you will get at last what? At last you will get x v plus x dv by dx equals 1 plus 2v divided by 2 plus v. Now this v will go here and will do minus. So then you will get dv by dx equals, this v will go here and it will turn into minus, x dv by dx equals 1 minus v square by 2 plus v. So at last you are getting what? You are getting, it is very rigorous, but you have to learn it. X dy by dx equals 1 minus v square by 2 plus v. You are getting this. So now turn into such a form that we will get logarithmic form. So dx by x equals what we are getting? 2 plus v by 1 minus v square into dv. Now, so dx by x equals, we can write what? 2 by 1 minus v square plus v by 1 minus v square into dv. Now integrate it. Integrate it. By integration, what we will get? By integration, we will get 2 into integration dv by 1 minus v square plus, you can write it in such a form, v by 1 minus v square. So you can write half into 2v, half into 2v by 1 minus v square into dv equals integration dx by x. So you have to do the integration of this portion, integration of this portion, integration of this portion. So dv by 1 minus v square. First you have to know a form, dx by a square minus x square integration has form 1 by 2a log a plus v by a minus v. This is the form, dx by x square minus x square 1 by 2a log a square minus x square 1 by 2a log a plus v by a minus v. So from here, if we put a equals 1, what we will get? Dx by and x equals v, what we will get? Dv by 1 minus v square 1 by 2 log 1 plus v 1 minus v. So if we put dv by 1 minus v square, we will get 1 by 2 log 1 plus v by 1 minus v, this term. And another integration was there. Another integration, what is that? Half into integration 2v by 1 minus v square into dv. So this can be integrated by what? This can be, you write d of minus here. I'm writing here. This can be write as minus of half into integration d of 1 minus v square by 1 minus v square, that is gx by x format. So you will get minus half log of 1 minus v square. However, and dx by x, you know already that log x plus c log c. So after doing all this integration, what you will get? After doing this all integration, you are getting 2 into half log 1 plus v by 1 minus v minus half into log 1 minus v square equals log x plus, as a constant you can take, as all the terms are logarithm, you can take log c. So at last you will get, by simplifying it, 1 plus v by 1 minus v into root over 1 by 1 minus v square equals cx. You are getting this. We are near to the solution. We are very near to the solution. So this can be written as 1 plus v by 1 minus v into root over 1 plus v plus into 1 minus v equals cx. So root over 1 plus v, this will be cancelled, and here it will be root over 1 plus v. So you will get here if we write, we will get root over 1 plus v by root over 1 plus v divided by 1 minus v whole to the power 3 by 2 equals cx. Now square both side. Square both side. Squaring both side, what you will get? Squaring both sides, you will get 1 plus v divided by 1 minus v whole cube equals c square x square. So now we have put what? We have put already what? We have put, no, is it? Sorry. Capital Y equals v into x. We have put here. So v equals what we can put? Y by x. V equals y by x we can put. So v equals y by x if we put, we will get 1 plus y by x divided by 1 minus y by x whole cube equals c square x square. So after simplifying it, you will get x square x plus y divided by x minus y whole cube. X square x plus y divided by x minus y whole cube equals c square x square. Equals c square x square. So what we can write? We can write here capital X plus capital Y equals c square x minus y whole cube. Now firstly what we have put, x equals capital X plus h. So capital X equals x minus h equals what we have got, x minus 1. Similarly y equals capital Y equals, we have can write put y minus 1. Now put this capital X equals x minus 1 and capital Y equals y minus 1, because our solution, our problem is in old variable x, small x and small y, and we are working with new variable capital Y and capital X. So we have to do that now. So if capital X plus capital Y equals c square x minus y whole cube, x equals small x minus 1, x minus 1 plus y small y minus 1 equals c square, capital X small x, this will be small x minus 1 minus y plus 1 whole cube. So this is the solution. This is the equation reducible to homogeneous. Now how it can be written as homogeneous? It can be written as homogeneous if you write small x plus small y minus 2 minus c square small x minus 1 minus y plus 1 whole cube equals 0, or small x plus small y minus x plus y minus 2 c square, this minus 1 plus 1 will be vanished, whole cube equals 0. So this is, that's why it is the equation reducible to homogeneous equation. So that's it for today. This is our today's discussion. We will discuss more about differential equation in our next videos. So for today, goodbye. Thank you for watching.